Hello, Professor. If you're watching this, that means something devastating has happened to our project and we were unable to present it. That's why we are creating this video in case something goes wrong on demo day. Let's go over our project. So our project's idea is using a computer microcontroller and a camera, specifically an OV7670, to do some on-the-edge machine learning object detection to detect our hands and our hand symbols, to then send to the embed and do some distance detection to be able to control a computer as a, I guess, easier to control device for people who are struggling with some sort of hand controls.
Motor control.
Motor control. Right, so let's take a look. So we have two MCUs. First, we have the Arduino Nano BLE33, and that is specifically only for doing the machine learning and object detection. So we have connected it to the OV7670, and now we have the camera working. You can see in the image, that is the trace of the camera. In the background, you see the background picture, but if I put my hand there, we can see my hand shows up in the picture, and it's trying to do some sort of prediction. Next, we take the predicted value out of the Nano BLE and we send it to the Arduino. Jason?
Okay, so this is, the setup is we have the ultrasonic sensor that we used in lab, and the ultrasonic sensor, we kind of subdivided the next 18 centimeters from 6 to 18 centimeters into 4 zones. The 4 zones the middle 2 quadrants allow you to slowly either increase or decrease the value, kind of like a scroll wheel on a mouse. The outer 2 zones allow you to do it faster, about half the speed, twice the speed. And the rest are just push buttons for debugging purposes, and also the mini USB dongle, which is conveniently the same port type as the embed. So we can connect it all the way to our laptop, which we will shortly demonstrate. You can easily scroll. I should probably move this over so it's in the same frame, right? When we demonstrate.
I think you should just record from this angle.
Like that? It's a pretty bad.
Can you catch my hand?
No, I can't do all 3. I'll just put it next to you. It's fine. Yeah. Okay. But yeah, that is the short thing, and you'll understand it when we actually get to it.
Right. So
Why did the lights turn off? Okay, we're good. Oh, it's on there.
no big deal.
My hand.
No big deal. No big deal. No big deal.
Okay.
I'm going to go a little bit more in depth about this Arduino. So basically how the Arduino does object detection is we basically first just took the Arduino and took some photos to create our training data set. So we connected this to the computer and we took the input from the camera and saved some images to our file system. We got approximately 50 images for each type of classification, which would be a fist, a thumbs up, a V, and hand, as well as some unknown figures such as this maybe, and this. And then we also got some background images, which are our non-target classes. After that, we did some of data pre-processing and data post-processing, where we took the pictures we took, because 50 pictures per class is definitely not enough to classify a good neural network. And we did some sort of translation and adding noises and rotation of the images so that we can have a larger data set. In the end, we ended up with about 3,000 photos in our data set just from taking the original 300 photos and rotating them, adding some noise, making it darker, making it brighter, so we can make our model slightly better. After that, what we did is we took those images and we headed over to Edge Impulse and we used one of their pre-trained neural networks. And with that, we were just able to train the final layer of the neural network to be more adjusted to our situation. After doing that, we took the model, which then got compressed and exported into a format that is applicable for Arduino. We had the choice between C++ and Arduino, but since we're working on such a microcontroller that has lots of limitations due to RAM, it was best to do Arduino as it was able to make some better optimizations. After doing that, we exported the model, and now we are here where we can see that the model is doing some predictions for us. Then, once the model makes a prediction, we take just a digital signal and we send it over to the Arduino for the rest. So, to explain what happens, we need to go and we need to throw a signal. So, what is our first signal? Our first signal can be thumbs up. If we go, we want to put a thumbs up signal, and if we look at the prediction is clearly thumbs up. And I'm going to move my hand away. So now we are predicting thumbs up. What does thumbs up do, Jason?
Yeah, it scrolls.
Thumbs up scrolls. So if we go to our distance monitor and we go closer, it begins to scroll, scrolling upwards.
You should probably reset the zoom.
If I go closer, it scrolls quicker. If I go to the middle, it tends to stop. And if I go farther away, it goes. So if I remove a distance, it just auto scrolls. So let's keep that distance there for now. This will make more sense in the future. Now, we can have a stop feature, which means that nothing will be controllable, as in peripheral don't do anything. This would be a hand gesture. So if we want to go throw a hand gesture. Let's try to match it. See, hand gesture, great. So now we're predicting hand. Even if there's no eraser, nothing happens. There's no scrolling, there's no zooming, there's no volume. Put the eraser back for the next one. Now, let's try to do some V. If we go V, this one's a little harder to predict.
Do you think your hoodie is getting in the way?
Okay, let's try to do, we already did thumbs up, let's do fist.
Okay, yeah, fist, and then we'll come back.
Fist. Okay, it recognized the fist. What is fist gonna do?
Zoom in and zoom out.
Zoom in and zoom out. So if we go closer, logically it should zoom out.
But there was a negative.
No, logically it zooms out. And if we go farther away from the sensor, obviously it's gonna zoom in. So wonderful. Once again, if we move the eraser away, it's just going to zoom in, but let's have a normal distance here, maybe like this, stop. We'll put a hand to stop the signal gathering. Let's
and it stops.
Hand, and now if we remove this, stops. Wonderful.
Now let's try and get this V.
Let's go back to the V. This is pretty weird.
Why is it not getting it?
Might be because the camera's a little tilted down. So let's tilt it up.
There we go.
There we go, 2 fingers.
Okay.
So yes, so the problem was actually, let me explain. So first, let me show that 2-finger works. So 2-finger, let's, what is 2-finger? 2-finger does volume. So if I zoom in, we can turn up the volume and listen to a wonderful tune. Let's say we get a little bored of the tune, because maybe this isn't our style, but maybe it is, but maybe we've heard it a lot of times today, because we've been doing this for a while. We can zoom out. We can turn down the volume. And now we have muted the video. Once again, we can go to hand. Let's get hand recognized, hand got recognized, and if we pull away, nothing happens. So a little bit what was happening. When we did our training model, I tested with this wonderful whiteboard behind here. And if you look here, there's a little bit part that is black, which is coming from the railing on here. When I was doing the training data, this whiteboard was a little bit closer and the railing was not in frame. Therefore, when we were trying to do the 2 fingers, which was a tricky class for our model to grasp, the bottom line there got it distracted and it was predicting other things. So that's why when we raise the model up a little bit so that it only shows the white part of the whiteboard, just like we were intending to do, when we go to show two fingers, it works much better. Let me like get it in frame. I can't even get it in frame. Two finger works much better.
Yeah, and now we can hear that wonderful tune again.
And that is our project presentation. Do you have anything else to add? Or is that it?
No, good vibes. I think this is a very cool project that
Yeah.
could help a lot of people with fine motor skills issues.
Yeah, I think this was a great project, and I appreciated working with Jason for this project.
As did I.
Peace out.